Alright, so in this video we're going to be solving the following problem in Python. So we're given an array of sorted integers, or in Python a list of sorted integers, and we want to find the closest value to an element that we're also given as input, which we'll call the target value or target number. So given an array, we want to find, okay, what is the number that is closest in that array to the target value that we're also given. And just as a note, this array that we're given might contain duplicate values, negative numbers, and that's just something that we should be aware of as we're solving this problem. So just to make sure that we understand what the problem is asking for, let's go ahead and step through two examples that I've listed here, and we'll see exactly what we need to, or what the problem is asking. So in this first example, we're given this input array with numbers 1, 2, 4, 5, 6, 6, 8, and 9. And we're also given as input this target number, target value, which in this case is 11. So we ask, what is the number in this array here that is closest to the value 11? So we expect an output of 9, because in this array here, the number that is closest to the number 11 is this value right here, 9. So the difference between 9 and 11 is 2. And that's the smallest difference that you could get from any of the other numbers in this particular array. So just to make sure that we understand this concept, let's go through one more example. So let's assume that we're given this array as input. So we have the numbers 2, 5, 6, 7, 8, 8, 9. And then the other element here, this target value, is 4. So in this case, the closest number in this array here to the target value 4 is going to be 5. So again, this is this 5 right here. That's because the difference between 5 and 4 is 1. There's only one integer between 5 and 4, and there's no other number in this array that's going to give you a smaller value in this case. So that's the gist of what we want to solve in this video. So just from kind of a naive perspective, maybe the first approach for solving this problem, something you might first try to do, is you might very naturally try to go through each of the elements in the array that you're given and calculate the absolute value, say, of the difference between the target element and the number that you happen to be processing in the array. So you would loop through this array, you'd process every single element, and you would keep track of whatever that smallest difference that you calculated was. So for instance, you might start a loop here, starting at the first element in this array, and you would check, okay, what is 11 minus 1? Well, that's 10. So that's the smallest difference value you've seen so far. So you keep going through the array. You check 11, again, the target element minus the element that you're processing in this particular case, which is 2. That is going to give you 9. So 9 is smaller than 10. So we replace the smallest value that we've seen so far by calculating the difference between those two elements is 9. So we just keep going in this fashion. And in this case, we won't actually reach the output value in this case until we get to the last element in this list. In this example down here, we would just keep going, and we wouldn't have a specific condition that would break out of this condition. We would just keep going through every element in the array. So for instance, as we started off here, we started off at number 2, target element is 4. Difference between these two, or the number of integers between 2 and 4, is 2. The smallest we've seen so far, we get to 5. Difference between 5 and 4 is 1. Between 6 and 4 is 2, and we would just keep going all the way to the end of the array. We're not doing anything really intelligent about breaking early or anything like that. So in this case, if we follow this approach, this is going to give us a runtime of linear complexity. So if we think that the size of the array that we're given is of size n, then this is going to take time proportional to the size of the array that we're given. So we're going to say it takes big O of n time to complete. So there is a way that we can actually improve the runtime. And the reason that we can do that is we can take advantage of something that we're not particularly taking advantage of in this naive way of approaching it, namely the fact that the arrays that we're given are sorted. So we're going to take advantage of the fact that the arrays that we're given are sorted and try to use that feature to improve our algorithm, to see if we can actually improve the runtime of it. So one thing that we're going to do, and perhaps this is obvious because this video is in the binary search playlist, is we're going to use the binary search idea to see if we can improve that. And generally, in the context of an interview or anytime you're seeing these sorts of problems pop up, if you have sorted input, you might want to try thinking about how you can apply binary search to the problem, because it's usually a very powerful algorithm, assuming that your input is sorted. So let's just go ahead and step through the binary search algorithm for, let's say, this example here, and we're going to do this with a bit of a twist, and I think that twist will help us in solving this problem. So let's just remind ourselves that when we approach binary search, the first thing we do is we kind of define our bounds, you should say. So like the low point, the high point, and also the midpoint. So the low point is the start of the array, the high point is the end of the array, and in this case the midpoint is this value here, 7. So we have this value here, 7, and what we can do is we can check let's say the points to the left and right of the midpoint. So I'm just going to write this down because it's going to get a little bit messy, but it'll help to kind of write these things down so that we keep track of what's going on. So we've calculated our midpoint, and the first thing that we've done is the midpoint in this case is 7. And now we can check the element to the right of the midpoint. So we can say right of midpoint, this is the value 8, and actually the left of midpoint, this is going to be the value 6. So what we want to do is we want to check how far away are these elements from the target. So the way we can do that is we can take the difference of those elements, the right and left bounds of the midpoint, and we can just subtract the target element. So we're just essentially asking how many integers is this away from the target element. So in this case, this is 4 units away and this is 2 units away. So what we've kind of come to terms with here is we found out that all of the elements to the right of the midpoint are going to give us a difference which is greater than 2. So 2 is smaller than 4, and we know that if we go to the left, we might potentially get smaller values as we keep moving to the left, but we know that as we go to the right, we're just only going to be increasing that difference. So that number is going to keep increasing because the array, again, is sorted. This is kind of the key point. Since we know that the array is sorted, that value is just going to keep increasing, and there's really no point to looking at that latter half of the array. So the nice thing that we can do is we can just say, okay, disregard that whole latter half of the array and just focus on the left portion. And that's exactly the idea behind binary search. And we can do that, again, precisely because we know the array is sorted. So what we're going to do is we're going to say, okay, I don't care about any of those elements. Let's go ahead and redefine our bounds for binary search and try this again. So again, what we do is we're just going to kind of get rid of all of those elements there. And we're going to set our new, well, the new low point is the same low point. It's the beginning of the array. The end point is now 6 because we've, again, just dismissed everything from 7 and beyond in the array as not being anything that's going to help us out get a closer value in this array to the target element. And then our midpoint in this case is 5. So we've got our end, we've got our left, and then we've got our midpoint. So the midpoint is 5, and we're going to follow the same algorithm as again. So midpoint in this case of the smaller kind of pared down array is 5, and then the right of midpoint is in this case going to be 2, and then the left of that's the left of midpoint. So the right of the midpoint is 6, left of midpoint is 2. And then we're going to do the same thing that we did again. We're going to check the difference. So 6 minus 4 and then 2 minus 4, and we're going to check how many units away are these elements that we're checking from the target element that we're trying to distinguish what element is closest to it in that array. So 6 minus 4 is going to give us a value of 2, and this is actually going to give us a value of minus 2. But one thing that we should probably be aware of is that we want to be calculating the absolute value of the difference, because we're really just concerned with how many numbers away from the target element is this thing. So we're just going to assume, I'm just going to assume that there's absolute value bars outside of all of these differences that we're calculating. So I'm just going to go ahead and remove this minus there. So in this case, 2 is 2 units away from 4, and 6 is 2 units away from 4 as well. So we're not doing any better there. Neither of those elements get us any better. But what we're going to do is we're going to say, okay, everything to the right of these elements is essentially not going to help us. So we're just going to do the same thing that we did up here with our midpoint being 7, is we're going to half the size of the array again and continue this process. So again, the process itself should be very familiar if you step through the binary search video. This whole idea is really just kind of a new way of describing the binary search algorithm, or it's just a different view of the binary search algorithm applied to this specific problem. So in this case, what we're going to do is our midpoint is going to be 2. So we're going to move on down. Midpoint will be then 2. To the right of that is going to be, so right of midpoint is going to be 5, and the left of midpoint, in this case, there's nothing to the left of midpoint, so there's going to be nothing here. So I'll just leave that as a dash. So what we do again is we check the difference between 5 and the target, and then there's nothing here, so we don't check anything there. This is going to give us a value of 1, which is the smallest difference that we've encountered so far. And after this point, we're going to conclude our binary search because we've gone through the entire array with binary search, and this is the lowest value that we've come to so far. So this is going to be the smallest value, and the one number in this array that gives us that smallest value is this value 5 here. So that's what we're going to return as output for this particular example. So hopefully that rough overview made sense, and what we're going to do now is we're going to take that idea and code it up, and hopefully when we kind of become more explicit with how this is actually going to be written up, the idea will become more clear, or at least more precise. So let's just go ahead and start to coding this up. So I'm going to get rid of these notes here, and then let's go ahead and write our function. So I'll call the function find closest number, or find closest num. It's going to take two arguments, the array A and also the target element that we're after. And then I'm going to go ahead and define a variable called mindiff, and this is going to be the variable that's going to keep track of the smallest number that we've seen so far with respect to taking the difference between the target element and the element in the array that we're looking at. So I'm going to set this initially equal to just a huge value, so I'm just going to set it equal to essentially Python's built-in version of infinity. And then I'm going to define the low and high points just as we did in the binary search video. So low is going to be the index that corresponds to the first element in the array, and then high is going to be the element that corresponds to the last index in the array. And then I'm also going to define a variable that I'll call closest num, which is just going to be the actual output that we want to expect from this function. So in the example up here, that closest num was 5, closest num in here is 9. It's specifically just the number in the array that is the closest number to the target element. And I'm just going to set that initially equal to none. So let's just, before we actually go and code up the algorithm, let's just take care of some edge cases. So edge cases for empty list, or let's say when the list is only one element. So that will be the two edge cases that we'll consider. So if the length of the array is 0, so if we have an empty list, we'll just return none, because there's no element in that array that fits the criteria, because there's no element closest to the target element that we're given. And if the length of the array is equal to 1, then the only element in that array that's possibly the closest number to the target element is just going to be the only element in that array. So we're just going to go ahead and return the only element in that array, which is a of 0. So those are the edge cases taken care of. So now what we're going to do should look very familiar if you've seen the binary search video in this series, the initial video, which covers the binary search algorithm. So we're just going to say while low is less than or equal to high, we're going to kind of go through our algorithm. So the first thing that we'll do is we'll calculate the midpoint of the array. So we'll say mid is equal to low plus high, and then we'll just divide that value by 2. Again, the reason for doing that is made clear in the initial binary search video, so I'll encourage you to watch that if you haven't seen it already. Sorry if I keep saying that, by the way. So the first thing that we want to do after we've calculated our midpoint is we want to ensure that we don't read beyond the bounds of the array. And one thing that we want to do after that is we want to check the left of the midpoint and the right of the midpoint. So in the example that we saw before, this array here, we checked that the midpoint initially was 7, and we wanted to figure out what is to the right and what is to the left of our midpoint. So to the right was 8, to the left was 6, and that's what we want to calculate now. So we've got our midpoint, and now we want to check what is to the left, what is to the right. So I just want to also make sure that I don't read beyond the bounds of the array, either to the left or to the right. So I want to check if the midpoint plus 1 is less than the length of the array, then go ahead and check the right point, because we're not going to read beyond the bounds of the array if this if statement passes. So if the if statement passes, then we're not going to read beyond the bounds of the array, and we can go ahead and set something that we can call min diff right is equal to the absolute value of the right element minus the target. So again, what we're doing there is we're saying, okay, we found our midpoint, which is in this case 7, and we're checking the element to the right of it, and this is 8. And so we're saying, okay, check what 8 minus the target element is, and that in this case it's 8 minus 4, and that's going to give us the element 4. That's exactly what we saw when we were stepping through this approach. And we're going to do a very similar thing for the left side as well. So we've got that, so let's go ahead and do the same thing for the left difference as well. And the way that we're going to check to make sure that we don't read before the bounds of the array, we're going to say if mid is greater than 0, then we're going to go ahead and say min diff left is equal to the absolute value of a of mid minus 1 minus the target. So again, what we're doing there is we're saying, okay, here's the midpoint 7. We calculated the right difference, 8 minus 4, 8 minus the target. And then we're doing the same thing on the left of the midpoint. So in this case, that's 6. We're calculating 6 minus the target. That's what we're doing here. And we're checking, we're storing that value in this variable min diff left. Okay, so we've got that. I'm just going to go ahead and put a comment up here so we can keep track of what we're doing. We ensure we don't read beyond the bounds of the list and obtain the left and right difference values. Okay, so we've got that. So now what we want to do is we want to check whether or not the values that we just calculated up above, we want to check if those are less than the minimum difference variable that we have defined up here. So if either of those are smaller than that, we want to go ahead and replace the minimum difference variable here, which is kind of the global minimum difference among the entire list that we're processing. We want to replace that with whatever one is smallest. So what we're going to do here, I'll just put a comment here, check if the absolute value between left and right elements are smaller than any seen prior. So again, it's kind of a global minimum that we're calculating. So if the minimum difference left is less than the global minimum difference, if that's less than that, what we want to do is we just want to go ahead and replace it. So we'll say min diff is equal to min diff left. And then likewise, if the minimum difference on the right side is less than the global minimum difference, we'll go ahead and say minimum diff is equal to min diff right. And I suppose another thing that we want to do within these if statements is we want to update this closest number variable as well. So in the event that the minimum difference is actually updated here, we'll go ahead and say the closest number is whatever one we happen to be processing. So it's a of mid minus 1, because again, this is the left element, right? So minus 1, which would be to the left of the midpoint. Likewise, over here, we would say closest num is equal to, I don't think I had an equal sign here, is equal to a of mid plus 1. So again, that's going to give us the element to the right of the midpoint. We update that closest number variable appropriately. Okay, so now what we want to do is we want to go ahead and kind of continue our binary search. So what we're going to do is we're going to move the midpoint accordingly, as is done via binary search. So this is kind of what we were doing. If we go back up to the example that we were going over earlier in this video, this list here, we calculated our midpoint 7, the right point of the midpoint and the left point of the midpoint, and then we found that, hey, you know what, we can disregard the entire right side of this because we're getting lower numbers on this side, so let's go ahead and throw everything to the right away. And what we're doing is we're moving the midpoint accordingly. So we updated the midpoint in this case to be 5 because that was the new high point was 6, the new low point, or the same low point really, was 2, and then our midpoint, updated midpoint, was 5 here. So that's what we're going to do, is we're going to move that midpoint appropriately. And again, this is more or less just directly verbatim from the binary search algorithm. So again, I hope this is the last time I have to say this. I apologize if I'm saying it too many times, but consult the binary search video and hopefully this idea will become clear as to why we're doing it this way. So if the midpoint is less than the target value, then we're going to go ahead and update the low point. So this is not what we saw in the example that we just went over. We would just update that to be mid plus 1. Otherwise, so else if the midpoint is greater than the target, this is what we saw in the above video, is we reset the high point. So high is equal to mid minus 1. So in that case, what we did is we found the midpoint here, right point, left point, and then we said, okay, so we want to update the new high to mid minus 1. So that is this guy right here. So that is our new high point of the array. Everything to the right of that is disregarded. We don't care about it. Okay, so moving right along. So now what we want to do is essentially have an else statement here. So otherwise, if the element is the target itself, Well, the closest number to it is itself. So for instance, if let's say we had a 4 in here, right? Let's say that the list here was 2, 4, 5. Well, we would stumble on 4, and if the number that we happen to be stumbling on is the target number itself, the smallest difference in that case would surely be 0. So the closest number to the target element is the number itself. So in that case, I'll just go ahead and undo that. In that case, we'll just go ahead and return the midpoint itself. So we'll just say else return a of mid. And then what we're going to want to do is we're just going to say return closest num. And that pretty much does it. So let's just go ahead and make sure that our algorithm is behaving as we expected. Let's go ahead and give it a run. So I'm going to say, let's say y is equal to find closest num. Let's go ahead and feed it a and 4. So if we go up to the up to the script here, the a array, the one that's most immediately defined, is this one here, which is the example that we went over here. And the target element is 4. I'm actually just going to go ahead and move these down here so we can actually see what we're dealing with. So I have our arrays down here, and just to be explicit, I'll comment that one out to make it clear that we're not using that one. So this is our array. We'll go ahead and say the target element is equal to 4. Just go ahead and say target here. And then what we'll do is we'll print out y. So this is what is returned from the find closest num function. So I'm going to write that. I'm going to clear the terminal, and then I'm going to say Python find closest num. And indeed, we get an output here of 5. So 5 is the number that is closest to the target element here. Going back up to the first example, just to make sure that we actually are doing this properly. Let me expand that. Let's go ahead and consider this array here with target element 11. And if this is actually coded up correctly, we should get the output value of 9. So going back down here, let's go ahead and comment this guy out, uncomment this guy, and replace target with 11. We expect 9 as output. We'll write that, and just to make sure, we'll print out y there. Let's go ahead and run this. So in this case, we do indeed get an output of 9, because 9 is the closest element to our target here, 11. So that pretty much does it for this video. If you have any questions, comments, or anything of this sort, please don't hesitate to leave them in the comment section of this video. As always, the code will be hosted on my GitHub page, and I'll leave a link to that in the description of this video. Thanks again for watching, and have a great day.